Okay, so here's problem 30, the kite problem. We've got the kite here on the end of a string, and I'm just going to go ahead and write in 200 because that's the length of the string at the moment of interest. And we're told that the kite is 100 feet off the ground, and that's constant. That's important to know. And it's moving this way. Let's call this leg, so we can draw this triangle, and this leg, of course, is we're just going to call x. And the kite is moving at a rate of 8 feet per second, which equals dx dt, in other words. That's its instantaneous velocity, dx dt. And they want us to get d alpha dt. Okay. So the fact that they give us the rate here in terms of dx dt, and we want to get to d alpha dt, that tells us that we need to get x as a function of alpha or alpha as a function of x, one or the other. Well, we can do that with the data we're given. So for example, x over 200, let me write in alpha here, equals the cosine of alpha. We could also do another function. It could be 100 over x equals tangent of alpha. That's perfectly valid. However, I'm more familiar with taking the derivative of a cosine, and I know I'm going to have to do that. So let's use this formula here, and let's rewrite it as follows. X equals 200 cosine alpha. Okay, so the next step that I'm going to use is a little different than the technique they recommend in the book, but it really comes down to the same thing. But what we're going to do is do something you did last year, which is take the differential of each side of the equation. And if you remember, it's very easy to do. You just take the derivative of x, or the differential of x, that's just dx. The derivative is 1 in terms of if f of x equals simply x, the derivative is 1, but the differential is dx. So you might remember that from last year. On the right side, we get 200. We need to take the derivative of cosine alpha, and that's negative sine alpha. But to make this into a differential, we have to write in d alpha. So now we have the differential for the left and for the right side of the equation. Now, the easy trick that we do is we just divide both sides by dt. That's perfectly legitimate. And the other thing we can do is, gee, what's sine of alpha, negative sine of alpha? Well, that's right up here. Sine of alpha equals 100 over 200, which equals 1/2. And of course, negative of that is just negative 1/2. So we can write this now as dx dt equals 200 times negative 1/2 times d alpha dt. And we know that we're given this, that's 8. So 8 equals negative 100 d alpha dt, or in other words, d alpha dt equals negative 8 over 100. And you can simplify that fraction or turn it into a decimal, but that's your answer.